Hello everyone, today we will solve some more problems based on chain rule. Here I have written the problem. Find the derivative of the following function. F of x is equal to sin x square. Yesterday we solved similar problem, right? Sin x square. What you have to do? First you have to consider this function as x. Now it's of the form sin x. Then you have to find the derivative of sin x. What is the derivative of sin x? Derivative of sin x will be cos x. But in the place of x, here we have x square. Is it clear? Now so this is done. Now you have to find the derivative of x square. Derivative of x square will be 2x. So this is the derivative of the sin x square. I hope you remember all the derivatives of a function. Now second one, tan of 2x plus 3. Now it's of the form tan x. You have to consider this one as x. Okay, what is the derivative of tan x? Derivative of tan x is secant square x, right? So this will be now secant square. What is x here? In the place of x, here we have 2x plus 3, right? So we have done with this tan. Now we have to find the derivative of 2x plus 3. So this is now derivative of 2x. 2 is constant as it is. Derivative of x will be 1 plus derivative of 3 will be 0. So next you have to write this one, I mean 2 into secant square of 2x plus 3. So this is the derivative of the tan of 2x plus 3. I hope you are understanding this one. See here, next one, sin of x square plus 5. So this one you have to consider as x, right? Now it is of the form sin x. What is the derivative of sin x? It is cos x. So this will be now cos. What is x here? In the place of x, here we have x square plus 5. Is it clear? X square plus 5. So this is done. Now we have to find the derivative of x square plus 5. So derivative of x square will be 2x. This is you are differentiating the function x with respect to x. So derivative of x square will be 2x plus derivative of 5 will be 0. So this is equal, finally we can write 2x into cos of x square plus 5. So this is the derivative of this function. This is the next problem here. It is given as similar to that, sin of ax plus b. See, this one you have to consider as x, right? Now it is of the form sin x. What is the derivative of sin x? It will be cos x. But in the place of x, we have ax plus b. So this is now cos x, but x is here ax plus b, cos of ax plus b into, this is completed. Now we have to find the derivative of ax plus b. A is a constant, okay? A and b are the constants here. So we will write a as it is. Derivative of x is 1 plus derivative of b is a constant, that will be 0. Remember this one. Here a and b are constants. A and b are constants. Okay? So the next one, secant of tan root x. Secant of tan root x. First you have to find secant x. Then you have to find tan x. Then you have to find the derivative of root x. Here 3 steps are there. Is it clear? First we'll consider this one as x. So now it's of the form secant x. What is the derivative of secant x? Secant x into tan x. But in the place of x, here we have tan of root x. So this will be now secant of tan root x. Is it clear? Secant x into tan x. In the place of x is now tan root x into tan of tan root x. So this is the derivative for the secant x. This is done now. Now we have to find tan root x. Consider now you are finding the derivative of tan root x. Is it clear? Tan root x. So consider this root x as some x. Now this is of the form tan x. What is the derivative of tan x? It will be secant square x, right? X is now root x. So this will, is it clear? So x is now root x. So this is now secant square of root x. So we have done with here. Secant is done, tan is done. Now we have to find the derivative of root x. What is the derivative of root x? It is 1 by 2 root x. Remember this one, derivative of root x is 1 by 2 root x, or else you can go with the method root x can be written as x to the power 1 by 2, right? So this is now nx to the power n minus 1. So this will be now 1 by 2 x to the power 1 by 2 minus 1. So this will be now 1 by 2 minus 1 will be, this is minus 1 by 2. So you can write 1 by 2 root x. So directly you remember this one, derivative of root x is always equal to 1 by 2 root x. So this is the derivative of this function. Next one more problem was there, that is cos of root x, right? You have to find the derivative of cos root x. We'll consider this as some x. Now it is of the form cos x, right? x is equal to root x. Now derivative of root x, what is the derivative of root x? Is 1 by 2 root x. Is it clear? You can't cancel this root x and this root x because this is an angle, this is a one value, remember that one. So this is the derivative of this function. So here, now is the next problem. You have to find the derivative of cos x cube sin square x to the power 5. This is, here you can see this is a one function, cos x cube is a one function, sin square x to the power 5 is another function. So here two functions are there, first function and the second function, and in between product sign is there. So here you have to use the product rule. Before that, see here this function, if it is a function is like this, cos square x square. Now this is a function, okay, cos square x square. Please try to understand this one. See now this is you have to consider as x. Now cos x square is x. So this is of the form x square. First you have to come with this one. First you have to remove this square. Okay, now it's of the form x square. Derivative of x square will be 2x. But in the place of x here we have this one. Is it clear? So this is now 2 into x is now cos x square. Now we have done with this one, right? Now cos of x square. So you have to consider. Now you have to find derivative of cos x square. So you have to consider this as x. Now derivative of cos x is minus sin x. So this will be now, I'll write here minus sin. In the place of x, here we have x square. Is it clear? Then this is done. Now we have to find the derivative of x square. Derivative of x square will be equal to 2x. I hope you understood this one. Now we have cos x cube sin square x to the power 5. As I told you, this is of the form product, right? You have to apply the product. What you have to do? You have to write the first function as it is, that is cos x cube. I'll consider this one. First function is as it is. Then d by dx of sin square of x to the power 5 plus you have write the second function as it is, as it is, that is sin square of x to the power 5 into d by dx of cos x cube. Yes? Now we find the now we will differentiate this one. So this is now cos x cube is as it is. Finding the derivative of this one. Similar to that, now it's of the form x square. Okay, what is derivative of x square? X square will be 2x, but in the place of x, here we have sin x to the power 5. So this will be now 2 into sin x to the power 5. So clear? So 2 into sin x to the power 5. So this is over. Now sin x to the power 5. Now we have to consider x to the power 5 as x. Now this is x to the power 5 is x. Now it's of the form sin x. What is the derivative of sin x? Cos x. But in the place of x, here we have x to the power 5. So this will be now cos x to the power 5. After this, you have to find the derivative. This is done, right? Now you have to find the derivative of x to the power 5. What is the derivative of x to the power 5? It will be 5 into x to the power 4. So this is the differentiation of this one. Now let's the next one plus. So this is first term is as it is. That is sin square of x to the power 5. Now derivative of cos x cube. This is of the form of cos x. Right? What is the derivative of cos x? It will be minus sin x. So here I will erase this one and I will write here minus sin. What is x here? In the place of x, here we have x cube. So this is done. Now we have to find the derivative of x cube, right? Derivative of x cube will be 3 into x square. So this is the derivative of the given function. Finally, you have to rearrange this one. Or else you can keep like this only, no problem. Okay, this is the next one. So there is, I have written there. The question is find the derivative of 2 into root of cot x square. Yes? Now 2 is a constant. Let me consider 2 as it is. Now it's of the form root x. You have to consider this as x. Now it's of the form root x. What is the derivative of root x? It will be equal to 1 by 2 root x. But in the place of x, here we have cot x square. So this is now 1 divided by, I hope you are understanding this one, 1 by 2 root of, what is x? Cot of x square. Cot x square. So this root is done, right? Now you have to find the derivative of cot x square. What is it? Now you have to consider this x square as x. Is it clear? Now you have to find the derivative of cot x square. For this you have to consider this as x. Now what is the derivative of cot x? Minus cosecant square x. So this will be now minus cosecant square of, what is the x here? X is we have considered as x square. So this is now minus cosecant square of x square. Now we have done with this curve. Now we have to find the derivative of x square. What is the derivative of x square? It will be 2 into x. Right? So here 2 and 2 will get cancelled. So finally you can write minus 2x cosecant square x square divided by root of cot x square. So this is the derivative of a given function. So here now is the next problem. Sin of ax plus b divided by cos of cx plus d. Now it's of the form, the function, two functions are there, f of x divided by g of x, right? You know the quotient rule. So to find the derivative of this one, you have to apply the quotient rule. What is the quotient rule? This says that you have to write g of x whole square, right? Then you have to write g of x as it is, derivative of f of x, it will be f dash of x minus, you have to write f of x as it is, then derivative of g of x, it will be g dash of x, right? So now we will apply this rule. So this is now divided by cos of cx plus d whole square. Okay. Now g of x is as it is, that is cos of cx plus d is as it is. Now you have to find the derivative of this one. Is it clear? You have to find the derivative of sin ax plus b. So directly I will write this one. So here you have to consider this as x, right? Derivative of sin x will be cos x. So cos of, but in the place of x here we have ax plus b. I hope you are getting this one, ax plus b. So this sign is over. Now you have to find the derivative of ax plus b. What is the derivative of ax plus b? A and b are constant. So a is constant as it is. Derivative of x will be 1 plus derivative of b will be 0 plus 0. Right? So this is the first one. Then minus f of x as it is. What is f of x here? Sin of ax plus b. I have to keep the numerator as it is, that is sin of ax plus b into derivative of denominator. Derivative of denominator means cos of cx plus d. You have to consider this as x. So derivative of cos x is minus sin x. So this is here minus into minus will be plus sin. What is x here? In the place of x here we have cx plus d. So this will be now cx plus d into derivative of cx plus d. What is that? C and d are also constant. So derivative of c into x will be c and derivative of d is 0. So this is multiplied with c. I hope you understood this one. Now we will simplify this one. See here. Let me write this one as cos of cx plus d whole square is there. 1 cos of cx plus d whole square will get cancelled with this one. What is remaining there? Cos of ax plus b into a divided by cos of cx plus d is remaining, right? In the first one plus second one sin of, here both are sin are there. So sin of ax plus b into sin of cx plus d into c is remaining divided by, so this is the denominator for everything. So divided by this will be now cos of cx plus d whole square. Understood? Now you can write this is cos of ax plus b into a. 1 by cos of cx plus d is there. 1 by cos will be secant. So a into secant of cx plus d into cos of ax plus b. Now plus here sin of cx plus d is there. Here cos of cx plus d whole square is there. 1 we can consider here. So it will be sin of cx plus d divided by cos of cx plus d. So sin by cos will be equal to tan. So I can write tan of, is it clear? Cx plus d, and here sin of ax plus b and c is as it is. I write c here, c into sin of ax plus b is as it is. Now what is remaining here? Divided by 1 cos of cx plus d. Right? 1 by cos will be secant cx plus d. So remaining with this is now secant cx plus d. So this is the answer. Actually no need to write this step. You can stop here also. This is also fine. No problem. See this problem. Prove that f of x is equal to modulus of x minus 1. X belongs to R is not differentiable at the point x is equal to 1. So you have to prove that this is not differentiable. I mean you have to show that in the differentiation left hand limit is not equal to the right hand limit. First let me write the derivative formula. F dash of x is equal to limit of h is tending to 0, right? F of x plus h minus f of x divided by h. Now this is a formula. Now this is equal to, at the point you have to check at x is equal to 1. Before that we'll substitute this one. Limit of h is tending to 0. F of x plus h. F of x is mod of x minus 1. In the place of x we have x plus h. Right? Here x is replaced by x plus h. So this will be now mod of x plus h, and minus 1 is as it is, minus f of x is mod of x minus 1 divided by h. Now you have to check at the point x is equal to 1, right? At x is equal to 1. So this is equal to now limit of h is tending to 0 mod of, I'll substitute x is equal to 1. If I substitute x is equal to 1 and 1 will get cancelled. This is mod h minus 1 minus 1 will be equal to 0. So this is 0 divided by h. Now we got this one as limit. Similar problem we have solved. Limit h tends to 0 mod h divided by h. Right? So this is now f dash of x. F dash of x is now 1. Now you have to check the left hand limit as well as right hand limit. Anyway modulus function is there. So left hand limit will be not equal to the right hand limit. We'll check this one. Limit of h is tending to 0 minus mod h divided by h. So this is equal to limit of h is tending to 0. The value of h is very close to 0 but it is less than 0. So obviously it will be negative. So modulus of h will be equal to minus h divided by h. So this is equal to now limit h and h will get cancelled. So this is minus 1. H is not there. So this is equal to minus 1. Is it clear? So this is the limit of h tends to 0 minus. Now we will find limit of h tends to 0 plus, that is modulus of h divided by h. So the value of h is very close to 0 but it is greater than 0. So obviously modulus of h will be positive. So this is now limit of h is tending to 0. So this is h divided by h and h will get cancelled. This is equal to 1. Here the left hand limit is not equal to the right hand limit. Since left hand limit is not equal to the right hand limit, the function f of x is equal to modulus of x minus 1 is not differentiable at x minus 1. See the next problem. Prove that the greatest integer function f of x is equal to greatest integer x. The value of x is between 0 to 3, not differentiable at x is equal to 1 and x is equal to 2. You know that greatest integer function is not continuous, but now you have to prove that it is not differentiable at x equal to 1 and x equal to 2. I'll prove this one x equal to 1. I'll explain this one x is equal to 2. You have to solve. Okay. Let me consider the definition, that is f dash of x is equal to limit h is tending to 0. Right. So this is f of x plus h minus f of x divided by h. So this is the definition of the derivatives. Now this is equal to limit of h is tending to 0. What is it? X plus h. F of x plus h will be f of x is greatest integer of x. So in the place of x you have to replace by x plus h. So this is the greatest integer of x plus h minus greatest integer of x divided by h. Right? Now we are checking the point at x is equal to 1. So substitute x is equal to 1. So this will be now f dash of 1 is equal to limit of h is tending to 0, greatest integer of 1 plus h divided 1 plus h minus greatest integer of 1 divided by h. Now we will check the left hand limit as well as right hand limit. So this is equal to limit of h is tending to 0 minus. So the value of h is very close to 0 but it is from the left hand side, right? The value will be negative. The value of h is very close to 0. If I consider the number line, so this is 0. So it is very close to 0 but it is from the left hand side. So obviously it will be negative. If you subtract some value from the 1, it will be less than 1. So if it is less than 1, the greatest integer of that will goes to 0. Right? So the greatest integer of this function will now 0 plus greatest integer of 1 will be 1 divided by h. So this is equal to limit h is tending to 0, 1 by h. Now if I substitute h is equal to 0, so the left hand limit will be equal to infinity. I hope you understood this one. The value of h is very close to 0 but it is from the left hand side. It is from the left hand side means it is a negative value. So you are subtracting some value from the 1. If you subtract some value from the 1, then it will be less than 1. So the value here less than 1, so the greatest integer of that function will be 0. Now we will check the right hand limit. So right hand limit will be limit of h is tending to 0 plus greatest integer of 1 plus h minus greatest integer of 1 divided by h. Here you can see that the value of h is very close to 0, but it is from the right hand side. So it is from the right hand side, means obviously it will be positive. So you are adding some number to the 1. So it will be more than 1. So the greatest integer of that function will be equal to 1. So this is now limit of h is tending to 0 plus the greatest integer of this will be equal to 1 minus greatest integer of 1 will be 1 divided by h. So this is 1 minus 1 will be 0 by h. So it is equal to 0. By this we can say that left hand limit is not equal to the right hand limit. So the function is not differentiable at the point x is equal to 1. Similarly, you have to prove that the function is not differentiable at x is equal to 2. See students, to solve differential problems, your limit basic should be strong. Without that, you can't solve those one. Remember that. If you don't know that, please practice those. Then only you solve these problems. Okay. Now we will see the derivatives of an implicit function. So far we are finding the derivatives of a function which contains only one variable. For example, f of x is equal to x cube or sin x, right? Or derivative of cube root of square root of x cube. Square root of x cube. What you have to do? Derivative, this will be this of the form x, right? Derivative of root x is 1 by 2 root x. So this will be 1 by 2 root x. In the place of x we have x cube. Then we are finding the derivative of x cube. It will be 3x square. Right? Such problems we have solved. So it contains only one variable. But now onwards we are solving the function which contains more than one variable. For example, if I consider y is equal to x square. Okay, now this is a one function. Here two variables are there. Y is also one variable and x is also another variable. Now you have to find the derivative of this function. The question will be y is equal to x square. Differentiate this function with respect to x. Is it clear? You have to find the derivative of this function with respect to x. What you have to do? You have to differentiate this one. So derivative of this one with respect to x will be now dy by dx. Is it clear? You are differentiating the function with respect to x. So this will be dy by dx is equal to derivative of x square. You are differentiating with respect to x, that will be 2x, or else what we can do, x square will be 2x. Then derivative of x you have to find. It will be equal to dx by dx. Usually we will not write this one, directly we will write this is equal to 1. Is it clear? See students, to solve the differential problems, your limits basic should be strong. Without that you can't solve those problems. Remember that one. Okay. Now this is the next concept, that is derivatives of an implicit function. So far we are finding the derivative of a function which contains only one variable. For example, if I consider f of x is equal to sin x square. Here only one variable is there, that is x, right? Or cos of sin of x cube. Here also only one variable is there, that is x, right? Such problems we have solved. Now we are finding the derivative of a function which contains more than one variable. For example, let me consider f of x or y is equal to x square plus y square. Y is equal to x square plus y square. Now this is a one function. You can either represent by y, or you can take this as f of x is equal to x square plus y square. Anyway, now you have to differentiate the function with respect to x. Is it clear? Now if I write dy by dx, now you are differentiating the function y with respect to x. Here similarly you have to differentiate this function with respect to x. So this is now y will be this. So this is now dy divided by dx. Dy by dx. I mean derivative of y will be dy by dx is equal to derivative of x square. You know that derivative of x square is 2x. Then you have to differentiate x. X will be 1. Why it is 1? Because we are differentiating x with respect to x. So this will be dx and dx will get cancelled. This is equal to 1. Usually we will not write this one. Directly we will represent this as 1 plus derivative of y square. Derivative of y square similar to the x square, it will be 2y, but here you are differentiating the function y with respect to x. So this will be now dy by dx. Is it clear? Now x square, you are differentiating with respect to x. So x square will be only 2x and derivative of x will be 1 and derivative of y square will be 2y, but you are differentiating the function with respect to x. So then you have to find the derivative of y. y. Derivative of y will be dy by dx. I hope you understood this one. Let me consider one more example. I'll consider f of x is equal to sin y. Okay, f of x is equal to sin y. Differentiate this function, differentiate with respect to x. Now I am differentiating this function with respect to x. So y f of x means differentiation will be, this is now dy by dx. As I told you, either you can consider this as f of x or you can consider as y. So derivative of this will be dy by dx is equal to derivative of sin y. Derivative of sin y, you know that it is equal to cos y. But if it is x, then directly you can write cos x. But here the variable is y. Variable is y. Then you are differentiating with respect to x. So you have So you have to find the derivative of y also. So this will be now dy by dx. Okay, I hope you understood this one. Let me consider one more example. Y is equal to x square plus cos square y. Y is equal to x square plus cos square y. Now you have to find the derivative of this function. You have to differentiate with respect to x. You are finding the derivative of this function with respect to x. So derivative of y will be now dy by dx is equal to derivative of x square is 2x. Derivative of x with respect to x, it will be dx by x dx. So it will be equal to 1. So no need to write that one, plus derivative of cos square y. So you have to consider this as x square, right? Derivative of x square will be 2x in the place of 2 into, in the place of x here we have cos y. Is it clear? Cos y. Then we have done with this square. Now we have to find the cos y. Derivative of cos y will be now minus sin y. So this is now minus sin y. Not only this much, here the variable is y, but we are differentiating the function with respect to x. So derivative of y will be now dy by dx. Then finally you have to collect the terms in the dy by dx and you have to write that. I'll explain it later. Just remember this one, okay? We'll solve some more problems. Next one, find dy by dx if x minus y is equal to 5. You have to differentiate the function y with respect to x. This is with respect to x. So directly you can do this one. What you can do, derivative of this first I write x minus y is equal to pi. Now we differentiate the function x with respect to x. So derivative of x with respect to x will be 1 minus derivative of y with respect to x. Derivative of y will be 1. Again you have to differentiate y with respect to x. So this will be now dy by dx. Is it clear? So derivative of pi. Pi is a constant, so this will be equal to 0. So directly I can write dy by dx is equal to 1. This is the one method. Or else x minus y is equal to pi is there. So you are differentiating y with respect to x. First write this one in the form of y. So there it is given x minus y is equal to pi. So I can write x is equal to pi plus y. Yes. So derivative of x will be 1 with respect to x. Derivative of pi will be 0 plus derivative of y will be dy by dx. By this also we can say dy by dx is equal to 1. Any one method is enough. Directly you can differentiate, or first you convert this one and write it in the form of y is equal to, then you differentiate. Okay. This is the next one. See, it is given that y plus sin y is equal to cos x. Find same it is dy by dx. You have to differentiate the given function with respect to x. Derivative of y with respect to x, it will be dy divided by dx plus derivative of sin. What is the derivative of sin y? It is cos y, but you are differentiating with respect to x. After the completion of this one sin, you have to find the derivative of y. So derivative of y will be equal to dy by dx. So this is equal to derivative of cos x. Derivative of cos x will be equal to minus sin x. And derivative of x is equal to 1 because you are differentiating with respect to x. Now finally you rearrange this one. You can take dy by dx common. If I take dy by dx common, remaining with 1 plus cos y is equal to minus sin x. By this we can say that dy by dx is equal to minus sin x divided by 1 plus cos y. I hope you understood this one. Okay, finding the derivative of a function which contains more than one variable. One more problem. Find dy by dx and you have differentiate with respect to x. Cos x square sin. Here you can see this. Here two functions are there, right? One is cos x square and the one is sin x. So this is the first function and this is the second function. So product of the two functions are there, right? So what you have to do? You have to apply the product rule. You know that first function as it is I have to write. That is cos. Is it clear? We are finding the, first if you want to write, differentiating the function with respect to x. We are differentiating with respect to x. First I will write cos of x square as it is. Now I have to find a derivative of sin. Derivative of sin 1 will be equal to cos y. Not only this much, we are differentiating with respect to x. So the derivative of y will be equal to dy by dx plus next I have to write sin y as it is. So this is now sin y into derivative of cos x square. So you have to consider this as x, right? Derivative of cos x is minus sin x. So this is now minus sin of, in the place of x we have x square. So we have done with this cos. Now you have to find the derivative of x square. It will be equal to 2x. Then finally you have to rearrange and you have to write it in the form of dy by dx is equal to. Is it clear? Let me consider one more example. Y square x square sin y square into x square. Here also two functions are there, right? This is the first function and this is the second function. You have to apply the product rule. So first we will find differentiate with respect to x. This is the example, okay? Now this is now sin y square is as it is. Derivative of x square. What is derivative of x square? 2x. Derivative of x with respect to x will be equal to 1 plus I write x square as it is. Now derivative of sin y square. So sin y square. Now you have to consider this as x, right? Derivative of sin x will be cos x. In the place of x, here we have y square. So this will be now cos y square. Next you have to find the derivative of this one. Derivative of y square will be equal to 2y. Then not only this much, you have to differentiate the function y with respect to x. So this will be equal to now dy by dx. Finally you have to simplify this and you have to write it in the form of dy by dx is equal. Important problems. Some more problems. Find dy by dx. 2x plus 3y is equal to sin x. dy by dx means you have to differentiate with respect to x. So this will be now directly we will do this one. Dy by differentiating with respect to x. Okay. Derivative of 2 into derivative of x will be 1 plus 3 into derivative of y will be equal to dy by dx. This is equal to derivative of sin x will be equal to cos x. Is it clear? Now we have to find dy by dx. So 3 into dy by dx is equal to cos x minus 2. By this we can write dy by dx is equal to cos x minus 2 divided by 3. So this is the derivative of a given function. Let's see the one more. See here, ax plus by square is equal to cos y. We'll differentiate this one with respect to x. Differentiation of this function with respect to x. Here a and b are constant. A into derivative of x is 1 plus b is constant as it is. Derivative of y square is 2y, but you are differentiating the function y with respect to x. So derivative of y will be equal to dy by dx. Remember this one. Whenever you have x, then the derivative will be equal to y. Whenever you have y, derivative of this will be equal to dy by dx. If you have t, then derivative of t with respect to x will be dt by dx. Actually, this is also dx by dx, but dx and dx will get cancelled. This is equal to 1. Remember that one. So this is equal to derivative of cos y will be minus sin y. Again we have here y, so derivative of y will be equal to dy by dx. Now we will collect the terms in the dy by dx. So this is now dy by dx into, so remaining here 2by plus sin y. Is it clear? So this is equal to minus a. So by this we can say that dy by dx is equal to minus a divided by 2by plus sin. So this is the derivative of a given function. No one will solve these many problems. I am solving these problems. The only reason is everyone should understand. That's it. Please understand these problems. See here what is given, xy plus y square is equal to tan x plus y. So you have to find the derivative of this function with respect to x. See this function here, x and y is there, two variables are there, and here in between product is there, right? Directly we can't solve this one. You have to apply the product rule for x and y. First we'll do this one. So product rule means first I have to keep the first function as it is, x into derivative of y will be dy by dx, plus I have to keep second function as it is, that is y, then derivative of x will be equal to y, plus next derivative of y square. Derivative of y square will be 2y, but we are differentiating with respect to x, so this will be now dy by dx. So this is equal to derivative of tan x. Derivative, I hope everyone know about derivatives. Secant square 1 plus derivative of y will be dy by dx. Now you have to collect all the dy by dx. So if I write the dy by dx here, what are the terms with dy by dx? Here x is there and plus this is 2y is there, and here plus dy by dx. When it comes here, this will be minus 1 is equal to remaining terms are secant square y. So this is now minus 1. So by this dy by dx is equal to secant square y minus y divided by x plus 2y minus 1. So this is the derivative of a given function.